afternoon and welcome. My name is Lucy van der Tas and I am Head of Talent Acquisition at ESA. This week is our first Careers Week, and in each of our live sessions we're sharing insights into the various aspects of working at ESA. I'd like to welcome you to today's second session, where we will look at what goes on in the final stages of an ESA mission, namely when it is launched and operated. We will also look at what is done with the data produced by our missions, but of course the main focus will be on how the work is done and the people we work with. Joining me today are Jutta Hübner, Spacecraft Operations Engineer, Benoit Geoffroy, Head of the Flight Programs Management Support Office, Henri Laure, Head of the Earth Observation Mission Management and Product Quality Division, and Santa Martinez, Science Data Processing and Archive Coordinator. Before we start, I'd just like to remind our viewers to put their questions in the YouTube chat if you would like them to be answered by us today during this session. Obviously, we'll try and answer as many as we can live, and my colleagues are in the background. Lorraine, Miriam and Nuria will be answering them behind the scenes. But please note, the focus of these sessions is on life and work at ESA, so we will not be going into deep technical detail, and such questions will be answered offline. So let's get started. Jutta, perhaps I can start with you. So perhaps you could introduce yourself and give us an insight into what a spacecraft operations engineer does.
Yeah, I'm Jutta Hübner, and I'm a spacecraft operations engineer for the Integral mission. And just starting a little about the mission, it's a mission that is 20 years in orbit now, and it's an ESA science mission. So it observes the high energy objects in the sky, in the gamma rays. And as what I think is really fascinating is the 20 years already. So 20 years in space, where's a laptop or something else that is 20 years old. Since satellites are really complex, you can only do mission operations in a team. So this is in my team. I'm responsible for the instruments, for the cameras on board the mission, the satellite, and there I'm calibrating. I'm doing calibration activities, planning special operations. Updating procedures, writing procedures, and for anomalies, it's kind of like in case there's an anomaly, it's a little like Sherlock Holmes. You try to figure out what it is, try to recover then, and yeah, for me it's the dream job because it's so diverse, so many different things and really interesting.
Oh, well, thank you. Well, we'll come back to that in some more depth in a moment. But perhaps I could ask you, Benoit, you work in the Space Transportation Directorate, which is primarily about launches, right?
Yes.
Perhaps you could talk about your job in this directorate and briefly share with us some of the directorate's key projects.
Yes. So basically, I've done all the job you can have on the launcher, from operating the launcher, designing the launcher, and finally preparing the missions of the launchers. So operational, and for what the directorate is preparing today, we have three spectacular projects with Ariane 6, of course, that will fly in a few months. Vega, that will fly in few weeks, and Space Rider, that is a re-entry vehicle that will fly in a few years.
Oh, thank you. Well, again, we'll come back to you for more details a bit later. So, Henri, perhaps I could ask you. You and your team are in charge of the management of ESA's Earth observation missions. Perhaps you can tell us a little bit more about what this means.
Yeah, actually, at ESA Association, the mission manager is the responsible of the mission during the operations phase, the exploitation phase. He's animating a team which is not only located in one establishment of ESA, but several establishments. We can talk about that later on. And he's really she are the making sure that the mission will reach the objectives which has been imagined at the start of the mission. That's basically, in a nutshell, what is doing a mission manager. I mean, it's also that, in general, with our people, we are in contact with many in the team, but also with many users, which can be scientists, which can be also operational, and also we are stakeholders, which can be either the ESA member state, but we also operate some programs of the European Union, Copernicus, and then the stakeholders in that case is the European Commission.
Okay, and how does your job operate with spacecraft operations?
Indeed, part of the team of the mission manager is located at ESOC. Like Jutta, they are in the Earth Observation Division at ESOC. we call them SOM, means spacecraft operation manager in the ESA language. They are very important. They basically control the Earth observation satellite, and they report any issues or any achievement to the mission manager located where I am, Esrin.
Okay, thank you. And Santa, last but not least. So your role focuses on the processing of data from ESA's scientific missions. So perhaps you can tell us about the programs you're supporting and how you interface with the scientific community.
So yeah, I'm working as part of what we call the Science Operations Center, and this is supporting the mission in several areas, and I'm focusing on the data processing part, so I'm coordinating and overseeing all the activities that have to do with the processing of the data. So our work starts really once we get the data from the spacecraft on ground, through the antennas, through the ground stations. And our main responsibility is really to convert this data that we get from this precious spacecraft into products that we can share with the scientific community. And as part of this, I support two specific missions. So one is Bepi Colombo, and this is an amazing mission that is on its way to Mercury. So it launched in 2018, and it's now halfway through the cruise phase, so we will get to Mercury at the end of 2025. And yeah, it's a very amazing mission that will explore a planet that is one of the least explored planets in the inner solar system. And then the other program or the other mission that I'm working and supporting is JUICE, and this is scheduled for launch next year, and it's going to study the Jupiter system.
And how do you interact with spacecraft operations in ESOC?
They are, of course, one of our main interfaces for spacecraft operations. So our responsibility as a Science Operations Center is also to prepare the observations that we want to execute on board the spacecraft, combining all the requests from the scientific instruments, from the science team, all the wishes that they have, and of course translate this into a timeline of commands, of telecommands that can be transmitted to the spacecraft. So this is one of our main interfaces with them. And as well, of course, receiving the data through the ground stations, through the ground systems, also to get the data on our side to be able to process and distribute to the community.
Thank you. So this is quite a unique session today because each one of us represents a different ESA establishment. So I'm working here in the Netherlands. I'm based at ESTEC, which we call the technical heart of ESA. It's the largest establishment, and we have around about 56-57% of the ESA workforce is located here. And from my perspective, I see ESTEC as being a little bit like a university campus. There's quite a buzz, there's a lot of energy. But the four of you come from different ESA establishments. So perhaps you'd like to say a few words about your establishment. So Santa, you're in Madrid, you're based at ESAC. So how would you describe life at ESAC?
Well, I was going to say unique, and I guess each of you will say probably the same because we all feel that our site is unique. So for me, it's unique. It's really, I mean, the diversity, from many different dimensions. So you get different backgrounds, expertise, education, nationalities, cultures, languages. So all of this. So to me, this is unique. But of course, you're going to say the same because this is at ESA level. The other aspect is science-driven. So our site is really focusing on science operations and making sure that we maximize the value that we get from the science missions. And this is all around. I mean, we are a small group of people, so we are 400 compared to ESTEC. This is quite a small size for an ESA site. And we are a family that are really focusing on the common goal. Whether we are looking farther into the universe, we are looking to the sun, or we are looking into our own solar system, our planets, we are all focusing on science. And this is very unique for me as well. And this gives us also the opportunity to collaborate. So another word that I would use to describe ESAC is that it's a very open and collaborative environment. We tend to share a lot what we do in our missions because we know that bringing different perspectives and opinions into the problems that we face every day will, of course, give us the best solutions that we can find. So that makes ESAC for me unique, but I know that for sure you're going to say the same about your site. So I think
we're all agreed on that. Our own establishment is the best. So Benoit, we have two offices in Paris. We have our headquarters, and then we have a second office in Daumesnil, and that's where you're based. And the focus there, I believe, is on the launches. It's quite specialized there. There's very strong cooperation with CNES, the French space agency. So how would you describe Daumesnil and the site in Paris?
So the site of Paris, of course, you have the heart of the headquarters that is former Nikis Street that, with a brand new headquarters under construction. And the other part is Daumesnil, completely devoted to launchers, where we share the buildings with the French Space Agency. The French Space Agency being the maître d'œuvre of the design and the production of the launch base in Kourou, the European spaceport in French Guiana. So this is properly unique. And, the interest being so close with the national agency and so specialized for the case of Ariane 6 is obvious. We build synergies and we meet people of really various nationality because all CNES are not French, and jobs. There are specialties that are sometimes a bit strange. We have specialists in concrete and civil engineering in the launchers, as well as computers, of course.
Thank you. Jutta, you're based in Darmstadt in Germany in our operations center. And people think of we have a problem Houston, so we probably say we have a problem Darmstadt. So what's it like working there?
So basically operations is like a big family. We share a lot. We share control rooms, we share expertise, we share teams, and we share passion and excitement as well, especially during launches, during kind of the early phase of a mission, and as well during special or critical operations. And on top, I think teamwork is key for us. So alone we cannot do a mission. Teamwork is kind of a major achievement, I would say, and a challenge on the other hand, but a lot of fun as well. So definitely, I think that really characterizes the uniqueness of ESOC.
Thank you. And Henri, you're based in Esrin. That's our establishment in Frascati near Rome. Our IT department is based there, but there's a strong focus on Earth observation activities. So how would you describe Esrin?
I would say it's a very cool establishment. Maybe the most Californian of the ESA establishment, because we get the sun, like at ESAC, but we also get a lot of visitors because of the nature of the activities at Esrin. There is indeed a lot in association with data management, the contact with scientists, the contact with the operational users, also a lot of students. In the session, before our session, we talk about the PhilLab at Esrin. All the activity also with industry, in that case, is not industry of the satellite, but industry of the data management, IT, you mentioned the IT department. We have also all the team developing Vega of the launcher. So it's really an establishment very much open to the world. And I believe it's the place where you have the best canteen at ESA.
Well, maybe we won't talk about food and the weather, because I think each establishment has something different to offer. But I think it's important for the viewers to know that this is a small tasting, if you like, of what our various establishments have to offer. There are more. We're based in other sites as well. As I said, ESTEC being the largest, I think that most people have the chance to end up here, and there is a lot to offer at ESTEC too. And our uniqueness, I think, stems from the wide range of activities that we do, from the conception of projects right through to delivering them for launch. And then having said that, I'd like to move on now to the challenges and the content of the job. And talking about launches, Benoit. So what would you say are the specific challenges when preparing for a launch and during the launch itself?
Wow. So, good question. I'm temporizing. Operation is all about fast decision making. And for launcher, I suppose for spacecraft, that's all the same. So as you come closer to the launch, to the show, it becomes very intense and your decision making has to be shorter to have all things set in order to, I would say, push the button. No one push the button, a computer does, but to be ready for the launch window. And this part is relatively crazy because you have hundreds of people focusing exactly on the same instant in time and the same moment, H0, liftoff. And this is completely, I think, completely specific to launching launch vehicles, and then smoothly along the mission we swap to another world that is space. And when the last tracking station of a launch system has completed the jobs, it starts working for the next department, next establishment of ESA to carry forward and get the spacecraft and check that first we are sure that he is where it's supposed to be, and start his new life.
Indeed, and Ariane 5, as we know, is one of the more accurate launchers on the market today. And I was extremely proud on Christmas Day when she launched Webb and placed Webb at a place where, in fact, it has the potential to save on fuel and propulsion so that the Webb lifespan could potentially be extended. That's quite exciting. But from what you've been saying, a large part of the launch sequence is autonomous. It's done by the computer.
Yes, of course, because in fact, if you simply consider that as power, the energy inside, when it lifts, the instant Ariane 5 lift off, it has the power or half the electrical power of the whole France. 45 gigawatts. It's completely sure that's a single number, I would say, and no more numbers. So it's absolutely huge. No man can handle that. So computers do it very accurately, as we have seen with Webb. We were extremely proud of the accuracy of injection, of the orbit injection for Webb. Really, it was top 10.
Well, it made my Christmas day. It certainly made my Christmas day, that's for sure. So coming to Jutta, you work on Integral.
Yes.
So I think you have a very interesting story that you can share with us about what recently happened with Integral and how the team pulled together to resolve a very challenging situation.
Right. It actually happened last year, and we basically lost control about on Integral. So what happened is that one of the reaction wheels was there was a high energetic particle from space that switched it off. That happens from time to time, not a big deal. Normally the satellite should go in a safe mode, where they should have the solar panels facing the sun, so that actually we have time, just get the energy, and then go back to normal operations. This safe mode didn't put us in the safe situation. So we basically started to rotate, and we lost control. So the solar arrays were not really illuminated anymore, so therefore we ran out batteries. We had to switch down the instruments, switch off the cryocooler, and try to regain the control again. So it was basically killing the rates. So what basically happened is that our thrusters were not reliable anymore, and this safe mode is based on thrusters. So basically we had now a safe mode that wasn't safe, and we then regained, after a long day and half a night, we regained the control again in operations. And that was really a teamwork experience. So Flight Dynamics helped there, industry partners helped as well, so everything. And during this corona pandemic, so it was a lot of offline, some people were at ESOC, and it was basically reviving the satellite. And afterwards we changed the operations so that we don't have the safe mode anymore, because it's not safe. And everybody was happy after this day, and it was basically a really cool moment to be there, but a lot of emotions as well.
So how did you feel when you first heard the news?
I was shocked because basically we thought about this event already. We knew that our thruster system didn't really work anymore at that point, but we thought, okay, we have enough fuel without kind of bubbles in the pipe so that we can have another safe mode. That was basically wishful thinking. It didn't work like that, so it was kind of like really shock. Okay, can we do it? And we really, short of really draining the batteries, so really on the low end of the batteries as well. So it was really, a bit of luck, I think, was there involved as well.
And the whole team worked basically 24 hours plus a day and a half all together.
It was basically after 17 hours we had everything back. But
17 hours?
Yeah.
Well, that's pretty good. 1/7.
Yeah, 1/7.
Oh, that's pretty good. So I can imagine that was a huge amount of relief.
Definitely, yes. Yeah.
Well, that's a big achievement. So coming to Henri. So what would you say are the key challenges of managing an ESA mission? I don't know, you have exciting examples like Jutta's with Integral. And what would you say has been the key differences between what you and your team do and Jutta and her teams do?
We integrate what Jutta's team are doing because in our association we have also the satellites operated by our colleagues in the directorate where Jutta belongs at ESOC. So we have also to deal with issues at satellite level. In our situation, often those issues could be related to space debris because we don't fly too high, up to 800 kilometers kind of, and this is where we have issues with space debris. So that's something which is always quite, I would say, difficult to deal. Then there are many other issues that challenge. The mission manager basically has to please his community, his user community. Sometimes it could be quite small community, but very important. We have a satellite called Aeolus, which measures the wind in the atmosphere. Not necessarily a lot of users, but very important. These are the national weather institution, and they need absolutely that wind information. And basically the mission manager has to be sure that whatever are the issues with the satellite, and particularly Aeolus is not that easy to deal with, he has to make the best out of the mission so that the weather institutions are satisfied. We have other mission which is almost the opposite. We have a lot of users, like Sentinel-2, which is that small model, which is close to you, Lucy, where we have probably like 200,000 users. 200,000 users. There also the mission manager has to make sure that the products that Santa has mentioned, the products are well calibrated, are very high quality with all the teams in charge of that, and that indeed the users are satisfied and resulting in a very high presence of the Sentinel-2 images actually in the media. I was just looking just before we were talking on Twitter. You see Sentinel-2 image maybe on an hourly basis, and one image I've just seen is an image just close to Nordwijk from where we are yesterday, where you see all the tulip fields. It's a beautiful image. On Twitter, put Sentinel-2, you will see it. So it's very diverse. And the other challenge, obviously, is to be sure we have enough budget to properly operate and exploit those missions. And then we have the major event, like that ministerial conference of ESA that we have at the end of the year. That's very important to prepare, to be sure we have the budget, and to, I would say, demonstrate that the mission is not only interesting, but deserves to be operated longer. So that's another major challenge. There are many others, but I will stop there.
So as you said, you're referring to the conference at the end of the year when the ministers of the member states get together and talk about the coming years.
Indeed.
So we're not just putting forward on the table new programs, but we're also putting forward on the table extension of existing programs.
Absolutely, which is very common to both in association, but also in the science directorate with Santa. This is important, but we need also to substantiate our proposal to extend those missions. In general, it works, but it's always very important. In general, the mission manager in charge of that, to really arrive with the best possible proposal, and also with, even if the mission is operated, we always try to do something new with the mission, to do things that we had not done before, without putting at risk completely the satellite, but in particular with the products, developing science or developing operations or applications with that mission. So it's a constant, we have some mission that we operate for a long time. We have in association 2 missions with more than 10 years. Actually, we have even one almost as old as Integral, 20 years. And that one, which is old, I have said, maybe it's time to stop because we have not that many users and so on. And I was immediately stopped by those users. I said, don't do that. It does not cost a lot. Please carry on, carry on. So this is also important in the context of the Minister Conference to remind that it's the investment of the past deserve to be extended a little bit more. Generally, the minister understand that, and it's not easy actually to switch off a satellite or mission because the data is really requested by many people.
And just to put it into the context, you said that this satellite mission has been operating now for 20 years. What was the originally planned duration of the mission?
Well, I think it was, I would say, almost an experimental mission. She developed here at ESTEC by the technical directorate called PROBA, which is a PROBA 1. And it was, I think, as far as I remember, it was meant to be operated 1, maximum 2 years.
And it's still
Indeed.
operating after 20.
Yeah, the one that I mentioned were 10 years, MOS and Cryosa, they were meant to be operated for 3 years, and we are now almost at 12 years. But that also demonstrates the fact that those missions have been well developed by the ESTEC team, but also that we have, with the other establishment, make sure that the interest in the data of those missions was there, and really make sure that the data was the highest possible quality, well calibrated during that long period of time. Actually, we have also a program at ESRIN where we call heritage space, where we make sure that the mission from the past, where the satellite is more in operation, is also maintained and make available to the people. So the heritage space program is one trademark of ESRIN. We work also with our colleagues at ESAC. And it's fundamental. Those data that we have accumulated are essential for climate change. And therefore, we have always, I would say, cleaning it, improving the processing algorithm, improving the information that we extract from those data.
Thank you. Santa, so a continuation on a similar theme. You're dealing with the data that are coming from the scientific satellites. So what's your perspective on that and your interactions with the scientific community?
Well, data is all they need, no? It's all they get, the precious benefit that they get from our missions. And this enables them to make new science discoveries, no? For example, in the case of Baby Colombo, they are still relying on data from a mission that is almost 10 years old, no? The NASA Messenger mission that was orbiting the planet in 2011, and also from the first flybys of the Mariner mission in the 70s. No? So they are still relying on that data. And of course, what we realize when we look at the data and with the scientific community is that we don't understand Mercury. We just don't understand the planet. The data doesn't fit the models that we have, so they need more data. They really need us to put the spacecraft in Mercury and to get more data so that they can answer all these questions and all these mysteries that the previous missions have left there. No? So they want to know more about the magnetic field. They want to know the origin, the shape, and why it's there, because they don't really understand. They want to confirm if there is water, no? If the ice deposits that we see in the polar regions, they are really coming from water, and what is the origin of this water. So all these aspects that they are really wishing to learn more from, and that will further the knowledge that we have of our solar system. So this is our main goal with the scientific community. The main purpose is really to make sure that the missions that we develop, that the systems, the data services, the products that we develop are really fitting the needs of the scientific community, and that, again, they are of the best quality that we can offer all the time. And I think it's important to highlight another domain that we have at ESAC as well, which is that the data, after the missions are collecting all this data, it becomes public. So it's really public for the scientific community to go and grab the data and use it for their own scientific research. So in particular for planetary science, that is my field, we have what we call a multi-mission archive. So it's an archive that collects the data from all the planetary missions. So Smart 1, that was a mission to the moon, ExoMars, Baby Colombo now, we have Rosetta as well, which is a very well-known mission. So all this data is in this archive in the best, again, shape and quality that we can offer, and it's there for the community to to explore, to explore what is there, what we can learn from our own solar system. So I think this is our main contribution to the scientific community, and we are really aiming to improve our services all the time for that.
Well, thank you very much. And I'd like to move on now to some more personal aspects of the job. So perhaps, Santa, if you wouldn't mind starting with telling us, what was your path to come to ESA?
Well, I've been working for ESA for 15 years now, and I think I first joined ESA as a trainee. So I was in my last year of university, and the opportunity just passed by. So I couldn't say no. I have to say that I'm not one of these people that want to be in the space business since you are really a kid. But then I saw the opportunity, and I joined ESTEC as a trainee, and it was fantastic. I mean, it was really a life-changing experience. And from that moment, I have never been able to go away from the space business. So I'm a telecommunications engineer by training, but I have been surrounded by scientists all my career, my entire career, so I would consider myself a hybrid. And from that moment, I joined the science division, and I'm still there as part of the Science Operations Center, and as I said, collaborating and trying to support and make our services as efficient as possible.
Well, thank you for sharing that. Jutta, perhaps you'd like to share with us your path to ESA.
Mm-hmm. So actually my passion for space was there all the time when I was little already. And I like large technical machines as well. And therefore I studied physics and astronomy. There I did my PhD. And, but I was always kind of involved in this experimental technical part. And during my PhD I actually had the chance to do a couple of space management projects, so I kind of managed small little projects together with ESA as well. And there I realized, okay, this is actually what I really like, so this is my passion. So I joined the German Aerospace Center afterwards as a project manager, and there I was responsible for the German part of several space projects, like for example Rosetta, the lander and the instruments and so on. And there, after 2 years, I realized it's actually a little too far away from the technical point of view. So I like to have the view now to the space project or to a satellite from different views, kind of from starting from the development, kind of the design phase, and then testing things, what I did during my PhD, and now doing the management. But so I thought, okay, what's missing? Operations. And so, I was lucky to get this job offer, and since now 12 years, I'm there as well. I never thought that I'm going to be at one position for so long, but it's really interesting, this teamwork experience, and it's just amazing environment.
Thank you, thank you. So a question for you, Benoit. Perhaps you could share with us how you and your colleagues and your teams interact with the other colleagues at ESA, so perhaps also in the non-technical and non-engineering roles, such as procurement, for instance.
Yes, so basically we interact with all directorates, all program directorates when there is a mission to prepare, to get to deal with the interfaces with a spacecraft and a launcher, Vega, Ariane, others, and this is the first part of the job, and this is the way the people of the launchers, the operational people of the launcher, the people preparing the mission of the launcher are going, discussing with other directorates first, but also with the satellite industry. So they keep their feet on ground, their head in space, but their feet on ground to prepare the mission. Of course, and alas, launcher cost a lot of money, and we have a pretty intense activity, either for the launch contract when for institutional missions when ESA is involved, either with procuring the launcher themselves or helping procuring the launcher themselves, or procuring let's say, fight against the obsolescence of the systems, fight against the flight anomalies, and we have programs for that with specific contracts. So our colleagues of the contracts are I don't think they like us too much, because we've always a bunch of activities to propose, very various, and always a challenge, always an emergency, and always a challenge for them. So at the end, we see a lot of people, and that's the substance of ESA, seeing all the people, all the directorates, all the family.
Okay, thank you. So Henri, as a division head, you manage a team of mission managers. When you're recruiting or selecting, or if you look at the team that you have today, what would you say are key competencies in terms of personality and behavior that you'd like to see in the team, or that you see are in the team?
The mission manager is a team leader, and therefore he should have the management skills. It's obvious. Most of the mission managers are rather senior in general. They are above 40, 45. But we need also new blood sometimes in the team. And right now, actually, we are recruiting an economist as junior professional in our team, 30 years old. He will join next month. So you see that it's not only engineer or association background. Sometimes we need other background. Together with me, I have also another team, which are the data quality managers, which tend to be younger and really make sure the data of the Earth Observation mission are the best possible quality, exactly as Santa is doing for the scientific mission. And there we need motivation, strong motivation, but also still the capacity to work with the external world, with industry, with institution. And talking about that, also what is fundamental, we have also in our team, we are also interacting with what we call the commercial world, the commercial Earth observation, where we also try to not only to stimulate the emergence of new space company, as we mentioned before in the previous session with Philip, but we are also anchor customer. Means we are customer of those commercial EO companies. We buy their data for science purpose or for operational purpose. This is quite substantial. So also that new role of ESA to be customer request to have different profile. Actually, the economists I just talked about will be more in that area, how we can best support the European commercial providers, including new space, in a role which is not necessarily the role that ESA had 20 years ago. So we evolve at ESA, meaning that we need also to have new profiles, which is important to say.
And in terms of behavioral competencies, I've been hearing teamwork, I've been hearing a certain drive, dedication. Are there other ones that you would like to see in the team members, perhaps in the teams reporting to the mission managers?
It's a team which is decentralized, the first thing. So people need to meet. In general, people have to listen each other and to respect each other. These are the basic. Each one have a specific competence, and they are absolutely all important. It's up to the mission manager to be sure that the team work in harmony, which is a case, I would say, not most of the time, all the time. Definitely, again in the previous session, we were saying what is ESA? ESA is the people of ESA. Is really the main resource. And something which is spectacular at ESA is not only the technical, the engineering, or the scientific skills, but also the human behavior skills. This is something which is quite strong at ESA, which is a chance we have. People tend to respect each other and can build with common achievement in a European spirit. This is what I like a lot, and which is what I also ask to the mission managers to be very open, to listen the stakeholders, to listen the users, and to be sure the team works in harmony.
Okay, thank you. So, Santa, perhaps a question for you is, can you think of one thing which you would have liked to have known about ESA before you joined ESA, and which would have helped you understand the sort of organization you were joining? Or do you find that it went smoothly?
Well, I think you learn as you go, no? It's, I mean, if you could have had more information before, probably you could have focused your career maybe in a different way, but it's really the case, at least for me, that ESA has encouraged me to always push my limits and look for more challenges and continues my learning. So I would say no. At the moment, I knew what I knew about ESA, and but if I have to give maybe an advice to someone, then I would say, prepare yourself. Prepare yourself. Look at the organization and what it's doing. The more you know, the better you will be able to establish maybe your network earlier, and to know more about maybe different technical areas that you may get interested in. So for me, again, I stayed in the same division, in the same department all my career, at least till now. There is still a few years to go, so I still may change my mind later on. But for me, it was, I wouldn't say anything in particular. But what you see is that once you are in, you get really a lot of means and resources to explore different areas and decide what you want to do with your career.
Thank you. Thank you. So, Jutta, how does working at ESA compare to other jobs that you've had before?
So working at ESA for me is really this team experience, kind of this working as a team together, a team of teams, kind of work together, these ESA people as well, with ESTA, commission manager and so on. So this is kind of for me the core of my current work. And before it, at DLR, it was kind of basically more hierarchical, so more everybody worked for himself, but that was kind of the core of my job there, so that it was more in the program director space. So there I was one person interacting with the project scientists on the other hand, or project managers. So that was totally different, the whole atmosphere as well.
Okay, thank you very much. So, Benoit, how do you see the profiles at ESA evolving? Let's put it in the context of your directorate to start off with. What were we needing in the past? What will we need in the future? Will we continue to need the same profiles today, or do you see changes?
Definitely, when I joined, the career of space, we needed pioneers. Beginning of the 2000. We were needing other profiles, people much more rational, much more professional, and definitely in the years to come, we'll need people more business-oriented and ready to renew the relation between the institutions, ESA or others, and industry or users of end users, let's say. And this probably will be a challenge for the people hiring the new staff now, definitely, because our job is to invent. Even in the old business of launchers, it's always to reinvent. So we have to find new profile, we have to find new ideas. And definitely the profile will change, but fresh blood is always the key, even if seniority helps to avoid a certain number of mistakes, let's say, or a longer track on the development of a service or a product.
And I was focusing there on the new profiles, but of course there's going to be a lot of profiles that we will continue to need. I would say that propulsion engineering, structures engineering, that sort of thing will remain a need for
yes, of course, the physics of space will remain the same. That's valid for launchers, for spacecraft, thermal aspect, propulsion, stabilization, control, data handling. All this will remain. But I think Henri was really explaining that the relation to data is is changing completely. Even in the launcher business, we have to face our new relation with data. We have to face the fact that we compare the data for all the launches to know what is going right and wrong, and we have to face one day that man is maybe a bit limited, and we have to introduce in this artificial intelligence to better deal with our data, to better safeguard our data, to better identify anomaly, or let's say proto-anomaly, as in some movie, the antenna may fail in 20 years from now, or in 20 weeks from now. You should change it, Mike. So we have to be ready for that, and the profile will change, and also the time will change. I think time goes always faster, and the cycle, we have to constantly reduce the time constants of our program and the development cycle.
Thank you. I'd also like to put a similar question to you as well, Henri, if I may, about the new profiles and the evolution, as well as the continued need for some of the more classical engineering or scientific
I like to
profiles.
continue on what Benoit has developed. Indeed, what I can see my long career is that, not shift, but evolution from space hardware. When I entered at ESA in the early 90s, it was a lot space hardware, the satellite, really the core or the launcher and so on. And we see more and more data management, the world of data coming. We need the space hardware, where we need the specialists, absolutely, launchers and satellite and all what we do. But the world of data is growing at ESA in all aspects, and therefore that's also more data analytics in all fields. I mean, Santa and myself, we are the symbol of that world. Even the mission manager at the end, yes, they have a satellite, but the most important is what will go out of the mission is through the data. We have to extract the most out of the data and so on. We have now developed the concept of digital twins at ESA. We have the digital twins of Earth, but there will be others. And we move in that world of data. This is a strong evolution, and that's obviously opened some different opportunities, especially from candidates in IT and IT world and so on. We mentioned the word of artificial intelligence and so on before with my former colleague Amanda. So definitely that's an area which is growing at ESA. There is no doubt about that. And this is an area also which is, you have ESTEC, which is very strong space hardware and so on. And you see the data world more on the other establishment at ESAC, ESRIN, also at ESOC somewhat, or strongly, and also an establishment that we have not mentioned, but which is important for us in association, EXAT, close to Oxford in England, where we have our climate change office. And that is all the world of data. So definitely, this is a profile that we need according to me in the future.
Thank you for sharing that. Indeed, what I've been hearing as well as far as ESTEC is concerned, as you were saying, the hardware, the satellite development, there will still be a continued need for the, I suppose, more classical engineering profiles, and we'll watch them evolve. Santa, would you have any comments you'd like to add to that?
Well, I agree totally with that, because I think data is becoming now the heart of our missions. No? This is what we want to preserve, the legacy that we will give to the future generations. And I think when we have the data, we have to find also different ways, different perspectives to look at it. And for that, we need these new profiles, maybe mathematicians, IT engineers, software engineers, bringing artificial intelligence into it. So we need to look for different ways to look at our data and to exploit it in the maximum, with the maximum capacity that we have. So I agree that this is one of the fields that we need to develop more.
Thank you very much. So we're coming towards the end of the session, and I'm looking to Miriam to see what questions have been coming in the Q&A.
So yeah, we have a couple questions that came in. One that came in right when the session began, so this person was ready to ask this question. How is commercialization of space activities affecting the work of each of our panelists?
Right, well, who would like to start? Do you want to
I
start,
could
Henri?
start definitely in association. It's very strong. In the previous session, we mentioned the activity we have in, I would say, in de-risking the development of some companies with the program that we call Incubed, but there are similar programs actually at ESA in other areas. Then I mentioned also that ESA is increasingly becoming a customer of services or data from commercial mission. We have that in association, and for that we use also budget actually from the European Commission, from Copernicus. So and we also move into the new space in buying basically also satellites. So there is definitely that approach versus new space, but not only new space, also with established companies in terms of data buy and or satellite capacity. Here I talk about the Earth observation world.
Of course. Benoit, have you noticed commercialization in the field of launchers? It's a typical institutional
Yes, that's
field.
not the best period for launchers nowadays, but that's why we are always trying to develop new services, launch services, and to this respect, we are developing now the Space Rider that is a re-entry vehicle. So basically, we will test very risky experiment in space from our users, and test them in space and bring them back on Earth to retrofit or adapt them to get the best data we can. And for the launcher themselves, Ariane 6 will be especially flexible in orbit. It will be a revolution. It will take some years to be confident and to be completely have the full trust in the launcher, but we'll learn to use it. The upper stage of Ariane 6 is a revolution in launchers.
Thank you.
So we adapt.
Thank you very much. Have any more questions, Miriam?
Yes, we do. When selecting engineers required at each site and having so many specialties, do you rather select people with a broad and shallow knowledge, so more of a general knowledge, or select a specialist that is really narrow and focused?
What do you think, Jutta?
I think it really depends. So for us, if we are specifically looking for a subsystem engineer, we definitely look for somebody with an experience in this area. If the vacancy is quite open, I think we are quite open as well in kind of who we want to have. So it depends.
Okay, thank you. Santa?
Yeah, I think it's the same. It really depends on the requirements of the vacancy. In some cases, you need experts on a specific scientific discipline or engineering discipline, but many times you need also people that have a system view, that are able to highlight problems at system level. So it really depends on the type of vacancy that we are talking about, but both cases would be relevant depending on the vacancy.
I think, to summarize, it depends very much on the requirements of the individual vacancy, and that I think we have room for both, and both ends of the spectrum and in between at ESA, so that's good to know. Thank you. Miriam, do we have any more questions? We'd have time for one more.
I think we have time for one more. Are there any possibilities at ESA for inexperienced recent graduates?
Henri, do you want to?
I believe our young graduate program is for that. It's extremely well known. I'm surprised by the question because the young graduate program of ESA is very famous. It lasted for a long time. It was even there when I started 33 years ago. Our Director General, Joseph Aschberer, was young graduate when I started. We started together. So definitely, this is the program, young graduate, when you just go out of master. Then I also like to mention the research fellow, which is one level above, which is really after the PhD. If you want to spend some 1 or 2 years at ESA, this is the other program. So young graduate and research fellow. And I would have to say that a lot of ESA staff come out of those two programs. Not all, but quite a lot.
Indeed, and I think what is interesting to note is that tomorrow's session, tomorrow afternoon, will be dedicated to the ESA entry-level programs and also what ESA is doing in terms of educational activities. So I think that this question will be answered in quite some depth tomorrow afternoon. So I think this brings us to the end of this session. So I'd like to say a big thank you. I'd like to say a big thank you to the four of you who have traveled in from the various establishments to join us today and to be able to present the different perspectives of your roles and activities and the establishments themselves. I think that was very important. I'd like to thank the moderators in the background, Miriam, Lorraine, and Nuria. And I'd like to thank our audience for joining us today. Don't forget to watch our other sessions. As I said, tomorrow is ESA entry-level programs and ESA education, and you can find the links on our careers website. Thank you, and keep watching.